Hi everyone, welcome to my video presentation. My name is Naila Amurita Chakravyun with student number 2024-32051. Okay, in this video, I will explain my lab report about Nmap scanning and network monitoring, and we will look at how to perform network recognition step by step and how to analyze data packets using Wireshark. So let's get started with the first part. Okay, the first step in this lab is Nmap scanning. But before we dive into the technical scanning, I first perform an installation verification and I had to make sure that Nmap was correctly installed on my operating system. And this is important to ensure that all commands and features work perfectly without any technical errors. Once the installation was verified, the next step was network interface identification. And here, I identified the target based on the IPv4 address detected on my scanning device. And this IP identity is our starting point for mapping the network condition around us. Okay, and now we enter the core part is the scanning process. I didn't just scan randomly, and I used 5 strategic stages to get accurate information. Okay, for the first scan is ping scan. If you imagine knocking on the doors of every house on a block, the ping scan is used to see who is at home or active. By adding a /24 prefix to the target IP, I scanned all address in the subnet, and I found a active device or host app. The information was quite detailed, showing IP address, MAC address, and device brand like Huawei, likely a router, and TP-Link. The second scan is regular scan. Once I knew which device were active, I focused on one specific target. The goal was to check the entry points or ports they have open. And out of 1,000 standard ports checked, I found 4 important open ports. Is ports 135, 139, 445 for file sharing or SMB, and port 808, which indicates an HTTP proxy path. Okay, the third scan is intent scan, and in this stage, I dug deeper to identify the resident inside. Nmap analyzed digital fingerprints to determine the operating system, and the results strongly indicate that the target is using Microsoft Windows, and I also detect a distance of 0 hops, meaning the target and I are on the same local network or LAN. Okay, the next scan is intents all TCP ports. Since some services are hidden on unusual port numbers, I scanned all 65,535 TCP ports. And this process takes longer, but it's very true. And I found a total of 14 open ports. Many were high number ports like 49,664 to 49,670. And I also noticed port 137 was filtered, meaning it's guarded a firewall limiting my access. Okay, and the last scan is slow comprehensive scan. This is the most detailed scan, and I didn't just check TCP but also UDP protocols, which are often ignored, such as time synchronization or NTP and UPnP. And using NSE scripting, I could even see technical details like the SMB file sharing version from version 2 to 3.1.1, and this can even successfully detect other nearby devices through broadcast signals. The Nmap data gave us a static picture of the target's condition and open ports. However, to see how the protocols interact in real time, we need a monitoring tool. Therefore, the next step is 3.2 is network monitoring and log analysis. Starting with the interface configuration in Wireshark. Okay, we begin with initial preparation. I used my Wi-Fi adapter and verified my IP address using the ipconfig command, and my IPv address was 192.168.100.223. Okay, next, I compare HTTP and HTTPS protocols. There is a huge security difference in HTTP. Data is not encrypted, so a not secure warning appears. On the other hand, HTTPS is secure because the data is encrypted, protecting user privacy. And to analyze the massive amount of data in Wireshark, I use several filter features. The first filter is ICMP filter. Used to is to this filter used to monitor ping traffic, and I could say the echo requests follow consistently by the echo replay between my IP and Google DNS 8.8.8.8. Next is IP source filter. I use this to see all activities where my device acted as the data sender. Next filter is HTTP filter. In this filter, I observe standard data traffic and detect a GET request for connect_test.txt with a 200 OK response, and meaning the connection was successful. The next filter is TCP port for port 80 and 443. In this filter, I compare port 80 for encrypted web paths and port 443, which show the TLS version 1.2 label, and the meaning the data was scrambled into secret code. The next filter is two-way filter. I use the two-way filter IP address equals 192.168.100.223, and this is a very crucial display filter in network analysis. Unlike the previous filter, this one works in both directions, and it shows every single packet where my IP address is either the source or destination. And the last filter is SYN filter. I use the tcp.flex.syn equals 1 TCP equals 1 filter to identify new connection attempts via the three-way handshake and to ensure a stable connection. Okay, in conclusion, this lab shows how important network mapping and protocol analysis are. With Nmap, we can map the gaps, and with Wireshark, we can monitor every data interaction to ensure our system is safe. I think that is all for my lab report presentation. I apologize any mistake in my explanation. Thanks for watching. I'm Naila Amorita Chakravarthy, signing off. See you in the next video.